Did you know that acceleration is a second derivative? Well, let me explain. We've got, in general, from our previous work, we know that the derivative of the derivative of y with regards to x is called the second derivative of y with regards to x. And so it'd be d squared y over dx squared. Or in function notation, it would be f double dash of x. That's previous work for us. We also have seen in the past the following. Acceleration is the rate of change of velocity with regard to time. You can write that as dv dt. Velocity is the rate of change of displacement with regard to time, dx dt. So if we think, okay, we've got a derivative and another derivative, acceleration is in fact the second derivative of displacement with regards to time. And we can see that summarized below. And this is important. So acceleration is dv dt, which is the derivative of x with regards to t, d squared x dt squared. Make sure you note that. And we're looking at motion in a straight line. Alright, sorry, I didn't mean to cross that out. We're looking at an example here, and then that'll be it for us. So we've got basically an object travels in a straight line. Its displacement from the origin is x meters at time t seconds. It's given by x of t is t times e to the negative t. That's the restricted domain, but that's not important in the questions I've selected. Just selected two here. So the first one asks you for velocity as a function of time. So velocity as a function of time is the derivative of displacement with regards to time. We know that. And that there will require the product rule. So the derivative of the first is 1 times the derivative of, times the second, I should say, not the derivative of the second, just the second, plus the first times the derivative of the second. So we've got negative 1 times e to the negative t, okay, in our product rule. After we get that line there, simplifying, we can factorize, and there is a factor of e to the negative t common to both terms. It'd be e to the negative t times 1 minus t. Okay, now for the second part, we've got to find the acceleration. Acceleration is the second derivative. So we've taken the first derivative, now we've got to take the next one, which is the second derivative. So it's the derivative of this result here is one way of thinking about it. So we have v dash of t, or in other words, another way of writing it in the other notation would be d squared x dt squared, the second derivative. Okay, so we have a product rule again. We have two terms there, and we have the derivative of the first times the second. You need to retain the brackets. So it's the derivative of the first times the second. And then we have the first times the derivative of the second. The derivative of 1 minus t is negative 1. And tidying up here, we have negative e to the negative t times 1 minus t. And negative 1 times e to the t is minus e to the negative t. We can look at the two terms here. All right, there's one term, there is another term, and there's a factor of e to the negative e to the negative t. Okay, and we can factorize that by taking that factor of negative e to the negative t outside. We get that there. Now, being careful, we've got negative e to the negative t, and inside the brackets then we've got 1 minus 1, which is 0. Oh, just spot a little error. I'm taking a factor here, just going back a step here, I'm taking a factor here of negative e to the negative t. Now that will yield the 1 minus t that you see there, 1 minus t. But if I'm taking a factor of negative e to the negative t, that'll be plus 1, I'm sorry. So there we go, spotted that just in time. And we've got 1 plus 1 is 2, take t. So you could write it like that. Maybe you could write it with the t take 2, which multiplies the whole thing by -1 times e to the negative t if you like. That answer there is okay, however. And there's our second derivative of displacement in regards to time, or in other words, acceleration for straight line motion.